Imagine you are developing a new software feature for months. You are finally ready to launch, but when it's time to deploy, nothing works. There are problems with the code everywhere. Dependencies fails to load and there are problems with performance as well. And now you are back to square one, trying to fix everything under a very tight deadline. Sounds stressful, right? That's the traditional software development world before CI/CD transformed the way we build, test, and release software. Hello, welcome to our new video. In this video, we are going to dive deep into the world of CI/CD. We will look into its definition. We will see how softwares were developed before CI/CD. What was the problem that CI/CD solves? And we will try to understand how it works. We will also look into some of the common tools that will help us to achieve CI/CD and why it's crucial in modern development of software. If you are new to this channel, kindly subscribe to get latest notification. Also, check out our other content where we talk about various Kubernetes concepts. Okay, let's go back in time. No, not in the history. Back in the software development time. Before CI/CD, software development followed a linear and a stage-based methodology known as the waterfall model. And here is how it worked. It contains 5 different stages. First is planning, where we do requirement gathering and entire scope of the project was outlined. This stage would often take weeks or even months. After planning, the design of the system was created, and this includes both designing the system architecture and software design. Then implementation. The actual coding stage comes next. Teams would spend months writing code for the entire project without really testing it and how it integrates with other parts. So individual developers will write its own code and does not know how the integration will work. Then comes the testing. Once all the code was written, testing team starts to test the application. QA team would find bugs at this stage, often leading to a lengthy bug fixing cycles that delayed releases. Then deployment. After testing and fixing bugs, the software would be ready to deploy to production environment, which could take days or weeks for deployment itself due to manual intervention and lack of automation. So, you can see, right, the biggest problem? The feedback was slow. Any bug or problem was usually detected late in the process, causing long delays. Teams didn't get to know about integration problems or deployment challenges until everything had been built. This led to a Big Bang release, where the entire system would go live at once, increasing the risk of failure. So you can imagine, right? All the components are going live all together, and if one component fails, everything fails. So that was the waterfall model. Let's take a real world example to understand how the traditional approach could lead to massive problems. Imagine a company developing a large scale banking software system. The development team spent 6 months coding the entire system without testing integration points. When it's time for testing, the QA team finds that the different modules don't communicate correctly, leading to a major failures. Fixing these problems requires rewriting significant portion of code, pushing the project timelines by another 3 weeks. By the end, the software is ready to deploy. Market conditions have changed, and the software's core features are now outdated. The result? Missed deadlines, increased cost, and a frustrated development team. Then the approach to software development underwent a significant transformation, and companies began adopting Agile methodology. The principles of Agile development played a crucial role in birth of CI/CD. Agile emphasizes on delivering small, working increments of a product in a cycles called as sprints. It focuses on collaboration, constant feedback, and adaptability. The idea is to respond to changes quickly, rather than waiting on a product for months only to discover it's no longer relevant by the time it's released. CI/CD took these principles and applied them to a software release process. Instead of waiting for the entire application to be developed and tested, CI/CD allows for continuous testing, integration, and deployment of small changes. Instead of going with a one big project, we divide our work into smaller chunks and we deploy them, integrate them, and test them. And this happens continuously. So, this reduces the risk of big bang releases and allows teams to quickly respond to bugs or feature requests. CI/CD transformed the way to make software development faster, more efficient, and more reliable. CI/CD stands for Continuous Integration and Continuous Delivery Deployment. Continuous integration (CI) refers to the practice of frequently integrating code changes into a shared repository. So every developer will push its code into a shared repository. Each integration is automatically verified by running some tests, ensuring that the new changes don't break the existing code base. While continuous delivery means that every code change is automatically tested and prepared for deployment. Although the code is ready to be deployed, the actual deployment may still be a manual process. And to achieve that, we have continuous deployment, which is an extension of continuous delivery, and it takes the overall process one step further. The code is not just tested and prepared, but automatically deployed to production without any manual intervention. CI/CD drastically shortens the feedback loop by testing code automatically and delivering new features to users quickly and continuously. As per Red Hat, CI/CD aims to streamline and accelerate the software development lifecycle and is an essential part of DevOps methodology, which aims to foster collaboration between the development and operations team. Both CI/CD and DevOps focus on automating process of code integration, thereby speeding up the process by which an idea like a new feature, a request, enhancement, or a bug fix goes from development to deployment in a production environment where it can provide value to end users. So, how exactly can you achieve CI/CD in your development process? Let's break it down into steps. First is code versioning and source control. We use a version control system like Git, where all code is stored in a shared repository or a version control system. Tools like GitHub or GitLab make it easy to manage branches, pull requests, and track changes. Now, every time a developer commits code, it triggers the CI/CD pipeline. So with the help of Git or GitHub, we can manage like multiple developers can commit their version of code into the repository, and whenever they commit, it will trigger a CI/CD pipeline. Then comes the automated testing. Testing is crucial to CI/CD. When code is committed, automated tests are run to verify that the new changes do not introduce bugs or break existing functionality. We will do unit testing, integration testing, and UI testing as part of this stage. Tools like JUnit, Selenium help us automate these tests. Whenever a commit happens, automated testing steps are triggered to ensure the reliability of merged code changes. Then we need a build automation. Once the code passes the test, it is automatically compiled and built. Built means packaging of a software with the source code and dependencies are compiled and built as a exe file or a jar file or a war file. This is where continuous integration shines. Tools like Jenkins, Circle CI are popular for automating the build process. This ensures that the application is always in a deployable state, even as code changes frequently. Then we need to have a artifact storage and a packaging tool. The build artifacts, that is the package software or container images, are stored in an artifact repository like a JFrog or Nexus. For containerized applications, tools like Docker create consistent environment across all stages. So this is the part of CI. So any successful CI means that once a developer's change to an application are merged, those changes are validated automatically by building the application and running different levels of automated testing, typically unit and integration testing, to ensure that the changes haven't broken the application. This means testing everything from classes and functions to different modules that comprises the entire application. One of the benefits of CI is that if automated testing discovers a conflict between new and existing code, it is easier to fix those quickly. Then we need to have a continuous delivery and continuous deployment. What does that mean? Once the code is built and tested, the next step is deploying it. So, continuous delivery means code is ready to be deployed. For continuous delivery, this step might still require a manual approval, but in continuous deployment, it happens automatically. Tools like Kubernetes, AWS Code Deploy, Azure DevOps, and Google Cloud Build are popular choices for automating deployments to production environment. Monitoring and feedback. So after deployment, it's essential to monitor the application for CPU utilization, memory uses to ensure it's working as expected. Tools like Prometheus, Grafana, and Datadog help you monitor performance and catch any errors early in the production. Okay, now let's talk about the tools you need to set up a proper CI/CD pipeline. For version control, we can make use of Git, GitHub, or GitLab. These are essential for managing your code base and tracking changes. For CI, we can use tools like Jenkins, Circle CI, Travis CI. These tools automate the building and testing of code after every commit. For containerization, we can use Docker. Docker will package your application and its dependencies in a consistent environment, ensuring it works the same across development, testing, and production environment. Now for orchestration, we can use Kubernetes. Kubernetes will manage the deployment, scaling, and operations of a containerized application. We have a separate video on Docker and Kubernetes. Please do check that out. For deployment automation, we can use AWS Code Deploy, Azure DevOps, Google Cloud Build. These services can automate the deployment process to various environments, that is staging, production, etc. For monitoring and alerts, we can make use of Prometheus Grafana. These tools monitor application health post deployment, ensuring there are no performance or security problems. There are other tools as well which comes handy to achieve production scale CI/CD, but these are the most common ones. Now, let's compare CI/CD with the traditional waterfall model. In waterfall, development, testing, and deployment are done in distinct stages. Feedback loops are slow, and bugs are often detected late in the process. This leads to a longer release cycle and higher cost due to delayed fixes. In CI/CD, the process is completely automated and is continuous. So code is integrated frequently and a small part of code is pushed to the repository and tested automatically and deployed faster. The feedback loop is short, allowing team to catch and fix problem earlier in the cycle. Here is another real world scenario showing the power of CI/CD. A startup is developing a new social media app. Instead of waiting 6 months to launch, they adopt CI/CD practice. As each new feature is developed, it's immediately tested and deployed to a small group of users. Feedback is received quickly and bugs are caught very early. This allows the team to continuously improve the app based on the user input, releasing updates weekly or even daily. Amazon, Shopify, Facebook make multiple deployments in a day using CI/CD, and they have experienced drastic difference in the release cycle. So CI/CD offers a more stable product, happy users, and the faster time to market. Of course, there are pros and cons to using CI/CD. So we can see speed. Features are delivered to users faster with more frequent updates. Quality is good. Automated testing ensures that code is tested early and often, reducing the chances of bugs in production. And teams collaborate better when code is integrated and deployed frequently. While on the other side, the setup complexity is there. So setting up CI/CD pipelines requires time, expertise, and the right tools. And also we have to do tool maintenance. So continuous monitoring and maintenance of the tools in the CI/CD pipeline can add an extra overhead. Also there is a cultural shift. Teams must adapt to faster release cycle and more frequent feedback loops. But once CI/CD is up and running, the benefits almost outweigh the challenges. In today's fast-over development world where users expect constant improvement and new features, CI/CD is a game changer. From startups to large enterprises, CI/CD enables teams to deliver high-quality software faster and with less risk. So that's it for this video on CI/CD. I hope you got an idea on what CI/CD is and why companies are shifting towards it. If you find this video helpful, please like this video and add your comments. Share it with your colleagues and subscribe for more tech content. Thank you and I'll see you in the next video.